For example, if you're showing a list of tweets, perhaps the user has liked only some of those tweets, not all of them. So we shouldn't hard code a value like false or true here. Instead, we should have a prop for initializing the status variable. But for the purpose of this exercise, it doesn't really matter. We'll look at a real world scenario later when we build a complete project. State management is a fundamental concept in React. So in this section, we're going to dive in and understand how component state is stored and updated. This knowledge is crucial for building complex applications, so be sure to watch every lesson and complete the exercises. Now let's jump in and get started. So you have learned that using the state hook, we can add state to a component. Now, there are a few things you need to know about the state hook. The first thing is that React updates state asynchronously, meaning not immediately. Let me show you what I mean. So here in the app component, I've used the state hook to declare and initialize a Boolean variable called isVisible. And here we have a button. When we click on the button, we set visibility to true. Now, I just told you that React updates state asynchronously, meaning not immediately. So if after this line, we do a console.log and log is visible, we are going to see the old value. Let me show you. So back in the browser, click, look, is visible is still false. So the update was not applied immediately. It's going to be applied asynchronously, meaning in the future. And this is done for performance reasons, because as part of handling an event, we could set multiple state variables. For example, we could set the name. Now, if every time we call a set function, React re-renders our component, we'll end up with too many re-renders. This is unnecessary. So for performance reasons, React takes all of these updates, batches them, and applies them at a later time, after this event handler finishes execution. So at that point, React applies all the updates at once, and then it will re-render our component with the updated state. Now, the second thing you need to know about the state hook is that the state is actually stored outside of a component. Let me show you what I mean. So back to our app component, I'm going to declare a local variable called count and initialize it to 0. Now, when handling the click event, I'm going to increment count by 1. Now, you know that in JavaScript, the variables that we declare inside a function are scoped to that function. So when this component finishes execution, our local variable is going to be removed from the memory. And that means the next time React re-renders this component, it's going to call the app function again. So our count variable is going to be initialized to 0 again. So the update that we applied here will be lost. This is the reason why we use the state hook to store the state outside of this component. So somewhere React is going to store all the state variables for this component, and it will automatically remove those variables when this component is no longer visible on the screen. And that brings us to the third point. We can only use hooks at the top level of our components. Let me show you what I mean. So let's use the state hook to declare and initialize another Boolean variable. We can call this is approved. So we're using the state hook to declare and initialize two Boolean variables. Now, these names that we have here, these are just local identifiers in this function. React is not aware of them. So when we use the state hook, we're just telling React that, hey, I need to store two Boolean values. React is not aware of these names, right? So somewhere React is going to store these values, most likely inside an array like this. So the next time React re-renders our component, it's going to look at this array, it's going to grab the first element and store its value inside this variable. So React relies on the order of these elements so it can map these values properly to the local variables in this function. And that's aware of these names, right? So somewhere React is going to store this array, these values properly to the local variables in this function. And that means we cannot use hooks inside if statements or for loops or nested functions because these constructs can impact the order in which the state hook is called. So to ensure a consistent order, we can only call hooks at the top level of our components. So here are the key takeaways. Firstly, for performance reasons, React updates state in an asynchronous manner. So to minimize unnecessary re-renders, it batches the updates, applies them all at once, and then re-renders a component. Secondly, when using the state hook, state variables are actually created and stored outside of a component in memory. React keeps the state in memory as long as the component is visible on the screen. And lastly, it's important to note that we can only use the state hook at the top level of our component. Now let's talk about a few best practices for choosing the state structure. So in this example, I've used the state hook to declare two state variables, first name and last name. Now let's imagine we want to show someone's full name. To do that, we don't really need to use the state hook to declare another variable like full name. We can simply render the first name, followed by a space, and the last name in our markup. Or if you don't like this approach, you can declare a local variable or a constant called full name. So this is where we calculate the full name. And then we can simply render the full name right here. So there is no need to use the state hook to declare a variable called full name. This is redundant and is something you should avoid. Now, sometimes our state variables are related. In those cases, it's better to group them inside an object. For example, let's declare another state variable, a Boolean called isLoading. We're going to use this variable to determine if we should show a spinner to the user. Perhaps as part of loading this page, we're going to call the server to get some data. Now, while waiting for the data, we want to set isLoading to true so we can show a spinner to the user. Now, in this example, the first two variables are kind of different from the third one. The first two are properties of a person object, but the third one is about the state of our page. So in this case, it's better to put these two variables inside a person object. So we call useState and give it an object with two properties, first name and last name. Now we get an object that we call person. Okay, this is preferred to two separate state variables. Just be aware that when using objects, don't go for deeply nested structures. So here we don't want to have a property like contact, which is an object that has another property that is address, which is yet another object that has street as a string. This is a deeply nested structure. Now, as you will see later in this section, updating an object with this structure is going to be a little bit difficult. So when possible, avoid deeply nested structures and prefer a flat structure. So let's quickly recap the best practices you learned in this lesson. When choosing the state structure, avoid redundant state variables like full name or anything that can be computed from existing variables. Now, if you have multiple variables that are related, it's better to group them inside an object. But when using objects, avoid deeply nested structures because they're hard to update. So prefer to use a flat structure. All right, let's talk about a fundamental concept in React called purity. What is purity? Well, in computer science, a pure function is a function that, given the same input, it always returns the same result. So if we call a function 10 times and every time we get the same result, we say that function is pure. But if we get different results at different times, we say that function is impure. Now, React is designed around this concept. It expects every component we create to be a pure function. So if we give it the same input, like the same props, it should always return the same JSX. And this is for performance reasons. So if the inputs of a component haven't changed, React can skip re-rendering that component, okay? But how can we keep our components pure? Well, we should keep any kind of changes out of the render phase. Let me show you what I mean. So for this demo, I've created a very simple message component where we render this piece of text, message followed by the count. Now, count is a variable that I've declared outside of this function. Now, in the app component, we have 3 instances of the message component. Now, if you go back to the browser, look, we get the same output, the same JSX markup. So this is an example of a pure component. However, if we come back to the message component and update the count variable, as part of rendering this component, Now we get a different result every time we call this component. So this is an example of an impure component. So to keep our components pure, we should keep changes out of the render phase. We should not change any objects that existed before rendering, like the count variable here. But note that to part of the same JSX markup. So this is an example of a pure component. However, if we come back to the message component and update the count variable as part of rendering this component, now we get a different result every time we call this component. So this is an example of an impure component. So to keep our components pure, we should keep changes out of the render phase. We should not change any objects that existed before rendering, like the count variable here. But note that it's totally fine to update an object that we create as part of rendering. For example, if we move this declaration down, now we are declaring the count variable as part of rendering, and it's totally fine to update it here. Because if we go back to the browser, look, again, we get the same result every time we render a message component. Here we have the same impure component we talked about in the previous lesson. So here we have initialized the count variable to 0, and every time we render a message component, we increment count by 1. So if we render this component 3 times, we expect to see message 1, 2, and 3. But if you go back to the browser, we get message 2, 4, 6. Did you notice this in the previous lesson? Why is this happening? Well, this has to do with the strict mode in React. So let's go to main.tsx. Earlier in the course, we talked about React DOM. I told you that here we're passing this component tree to React DOM for rendering inside the browser. Now over here, our app component is wrapped inside the strict mode component in React. This is one of the built-in components in React that doesn't have a visual representation. It's only there to catch potential problems. One of these potential problems is impure components. So when the strict mode is enabled, in development, React renders each component twice. That is why instead of message 1, 2, 3, we get message 2, 4, 6. So in this case, React renders each message component twice and takes the result of the second render. The first render is used primarily for detecting and reporting potential issues with our code, while the second render is used to actually update the user interface. That is why we don't see message 1, 3, and 5. Instead, we see message 2, 4, 6. To better see this in action, let's go back to the app component and remove these 2 instances of the message component. So we have a single message. Now, let's go to the message component and do a console.log. I don't know why my snippets are not working today, so I have to type out everything. Console.log. Here we say message called, and we can pass our count variable as the second argument. Now, let's refresh. Look, we have 2 messages in the console, message called 0 and 1. Look at the second message. This one is grayed out because it's coming from the strict mode. So starting from React 18, the strict mode is turned on by default, and as a result, React renders each component twice. With this, we can find impure components like our message component here. So we are not seeing the result we expect because we expected to see message 1, but we see message 2. So this is the strict mode. It only behaves this way in development mode. So when we build our application for production, the strict mode checks are not included and our components will render only once. Earlier, I told you that it's better to group related state variables inside an object. So here in the app component, I've used the state hook to create a drink object with two properties, title and price. Now, in this component, we have a simple button. When we click on this button, we want to update the price of the drink. Now, when dealing with objects and arrays, you should remember to treat them as immutable or read-only. So in this event handler, we don't want to modify any of the properties of this drink object. So we don't want to set the price to 6 and then call set drink and pass the drink object. This is not going to work. So if we render drink.price here, now look, if we click on this button, nothing happens. So React doesn't detect any changes. To tell React about state updates, we have to give React a brand new object. So instead of updating an existing state object, we should give React a brand new state object. So here we create a new drink. First, we need to copy the title of this drink object. So we set title to drink.title, and then we change the price to 6. And finally, we will pass the new drink to the setDrink function. With that, if we click on this button, the state gets updated. So just like props, we should treat state objects as immutable or read-only. Now, in this example, we have a very simple object with only a couple properties. But what if we had 10 properties here? We don't want to copy all those properties. That's very tedious. So instead of copying all these properties, we can use the spread operator in JavaScript to spread the existing drink object. This will copy all the properties of this drink object into the new drink object. And then here we change the value of the price property. Okay. Now, in this example, we don't even need to create a separate object. So let's delete these few lines. We can simply create a new object here. First, we spread the existing drink, and then we update the price to 6. That's better. Let's look at a more complicated example. So in this example, we are using the state hook to create a customer object with two properties, name and address, which is an object itself. So here we have two properties, city and zip code. Now, let's say as part of handling the click event, we want to update the zip code. So just like before, first we call setCustomer. Now we create a new object. First we spread the existing customer object. Now, one thing you need to know here is that the spread operator in JavaScript is shallow, which means when we use it to copy this customer object, it's going to return the existing address object in memory. So that means if we create two customer objects this way, both of them are going to reference the same address object in memory. This is not what we want. When updating state in React applications, we should make sure that our new state object is completely independent of the existing state objects. They don't share anything. So to solve this problem, here we need to set address to a new object. Now in this object, first we spread the existing address object, so customer.address. So we copy all those properties, and then we modify zip code and set it to, let's say, 94112. Let me save the changes. So the code is reformatted so you can see clearly. So we call setCustomer and pass a new object. In this object, first we copy all the properties of the customer object. So this will copy the name and the address. We set the address object to a new object, so this is completely independent of this address object over here. Now in this new object, first we spread customer.address. So we copy all those properties, which means city and zip code, and then we change the value of the zip code property. So earlier I told you that when working with state objects, you should avoid deeply nested structures, because the deeper this structure gets, the more complicated our update logic will be. So prefer a more flat structure to a deeply nested structure. customer object. So this will is which means the struct. Now the same concept applies to arrays. So if you have an array, we should not mutate or change it. Instead, we should give React a brand new array. So here I've used the state hook to create an array of tags. Now let's say when our button is clicked, we want to add a new item in this array. Now the same concept applies to arrays. So if you have an array, we should not mutate or change it. Instead, we should give React a brand new array. So here I've used the state hook to create an array of tags. Now let's say when our button is clicked, we want to add a new item in this array. Now we don't want to call tags.push because this modifies the original array. Instead, we should call setTags and create a new array object. Here, once again, we use the spread operator to spread the tags array, and this will copy all the items in the original array into the new array. And then we can add a new item like exciting. Okay. Now, what if we want to remove an object? Well, once again, we call setTags. Now, all arrays have a filter method, so we can call tags.filter. Here we pass an arrow function. So we want to get all the tags except, let's say, the happy tag. So tag should not be equal to filter. Okay. Now, what if we want to remove an object? Well, once again, we call setTags. Now, all arrays have a filter method, so we can call tag. Tags.filter. Here we pass an arrow function object. Well, once again, we call setTags. Now, all arrays have a filter method, so we can call tags.filter. Here we pass an arrow function. So we want to get all the tags except, let's say, the happy tag. So tag should not be equal to happy. Okay. Now, what if you want to update an object? So we call set tags. Now, there are different ways to do this. One way is to create a new array and copy all the existing items, and then we can modify the new array. The other option is by using the map method. So here we can call tags.map. Again, we pass an arrow function. Now here we can write an expression like if tag equals happy, we're going to change that to happiness. Otherwise, we're going to return the tag. So we're going to iterate over all these items. If the current item is happy, we're going to return happiness. Otherwise, we're going to return the tag itself. All right, now let's look at a slightly more complicated example. In this example, we have an array of bug objects. Each object has three properties: ID, title, and fixed. Now let's say when our button is clicked, we want to mark the first bug as fixed. So we want to update this array, right? So we call setBugs. Now in the previous lesson, I told you that to update an object in an array, we use the map method. So here we call bugs.map. Here we pass an arrow function. So bug goes to. Now we check the ID of the bug. If it's equal to 1, now we need to create a brand new bug object. So we add an object literal. Now just like before, we spread the bug object to copy all of its properties, and then we set the fixed property to true. Now otherwise, if bug ID is not equal to 1, we're just going to return the same bug object. So let's visualize what we have done here. In this example, we have an array with two bug objects, B1 and B2. As part of handling the click event, we created a new array with two objects. Instead of B1, we have B1 star, which is a brand new object, and we also have B2, the same B2 that we have in the original array. With this, we're telling React that the first object in this array is updated, and React will do the necessary work to update the DOM to match the component state. So what I want you to take away here is that we don't need to create a brand new copy of every bug object in this array. Only the object that's supposed to be. So as you have seen, updating arrays and objects without mutation can get a little bit complicated and repetitive. So in this lesson, I'm going to show you how we can use the Immer library to simplify our update logic. So here in the terminal, first we install Immer. The version I'm using is 9.0.19. Let's go ahead. All right. Now, back to our app component. We are working on the same example as the previous lesson. So we have an array of bugs, and we want to mark the first bug as fixed. Now, on the top, we import the produce function from Immer. Now, down here, let me comment out this line. Now, to use Immer, we call setBugs, but instead of using bugs.map, we're going to call the produce function. And as an argument, we need to pass an arrow function here. Now, by convention, we call the parameter of that function, draft. I will explain what this is in a minute. So draft goes to, and here's the body of the arrow function. Now, what is draft? Well, draft is a proxy object that records the changes we're going to apply to the bugs array. So imagine draft is a copy of the bugs array, so we are free to mutate or modify it just like a regular JavaScript object. So we don't need to map anything, we don't need to create copies. We can go in this object and make any changes. Behind the scenes, Immer keeps track of those changes. Then it will create a copy of the bugs array with our changes applied. Let me show you how this works. So imagine draft is the array of bugs. So to find the bug with the ID of 1, we say draft.find. Here we pass an arrow function. We are looking for a bug with the ID of 1. We get the result and store it here. Now, if we find this bug, we simply set bug.fixed to true. So we are mutating this object just like a regular JavaScript object. So if you don't like this style of updating objects in an immutable way, you can use Immer to simplify your update logic. Now, to verify that this is working, let's render a bit of markup here. So just above the button, we're going to map the array of bugs. We get each bug, and now for this example, let's just add a paragraph element here. We set the key to a unique value, in this case, bug.id. Now for the text, we're going to render bug.title. Now right after, we can write an expression like of the button, in this case, bug.id. Now for the text, we're going to render bug.title. Now right after, we can write an expression. When we click, if bug is fixed, we're going to render fixed. Otherwise, we're going to render new. Back to the browser. So we have 2 new bugs, but when we click on this button, the first bug becomes fixed. Otherwise, we're going to render new. Sometimes we need to share state between components. For example, let's imagine we're going to build an e-commerce application. So typically we have a navigation bar on the top where we can see the total number of items in the shop. Shopping cart. And below that, we have the shopping cart component. Now, as the user updates or removes items from the shopping cart, the number of items in the navigation bar should get updated in real time. So these two components need to share state and be in sync. How can we do this? Well, here's our component tree. So on the top, we have the app component, and below that, we have the nav bar and cart components. Now, let's imagine that we have used the state hook in the cart component to store the list of shopping cart items. Now, to share this state with the navbar component, we have to lift the state up to the closest parent, in this case, the app component. Now that we have this state in the app component, we can share it with its children using props. So both the navbar and cart components are going to receive the list of shopping cart items as props. Let's see this concept in code. So here in the app component, we use the state hook to store the list of shopping cart items. Now for this demo, I'm going to pass an array of strings like product1 and product2. But in a real application, instead of strings, we have product objects where each product has properties like ID, title, price, and so on. Let's not worry about those details because they're irrelevant here. So here we have a list of shopping cart items. We can store that in a variable like cart items. Now that we have defined the state here, we can pass it to the children as props. Before we do that, first we need to create a couple of components. So back in the components folder, let's add a new file called navbar.tsx. Here we use our shortcut to create a function component. Next, we need to define the shape of props. So interface props. Now here we have two options. One option is to pass all the shopping cart items here as an array. The other option is to pass only their count. What is the difference? Well, if all this component needs is just a count, it's better to pass the count. But if you need to have access to all the shopping cart items, it's better to pass all of them here, okay? So I'm going to rename this property to cart items count and set the type to a number. Now we add the props here and destructure it, okay? And then we render the number of shopping cart items, okay? We're done with this component. Now, let's move on to the next component. So we add a new component called cart.tsx. Let's create another component. Now for this one, in the props, we need to include the shopping cart items. So cart items is going to be an array of strings. Next, let's add that here. We destructure it. Next, we come here, add a UL element. Now we have a compilation error because we are returning multiple elements. So we need to wrap them inside a fragment. Okay, now let's write an expression. We grab cart items and map them to list items. So for each item, we render a list item. We give this a key, which is going to be the item itself, which is just a string. And we're going to use the item as the label as well. We're almost there. Now, let's go to the app component and add these two children. So the first one is navbar, which requires cart items count. We set this to cart items dot length. And below that, we add the cart component along with the cart items. Pretty simple so far, nothing new. Now, back to the browser. So the navigation bar is saying that we have 2 items in the shopping cart, and here are those items. Now, let's add a clear button in the cart component to clear the shopping cart. So back to the cart component, right after the UL, we add a button called clear. Now, what should happen when the user clicks on this button? Well, earlier I told you that we should treat the props as immutable or read-only. So we are not going to modify this object here. Instead, we need to notify the app component that the user clicked on the clear button. So all the changes to the state should be done inside this component. So as a rule of thumb, remember, the component that holds the state is the one responsible for updating it. So back to the cart component. Here in the props, we need to add a new property on clear, which is going to be a function with no parameters that returns void. Now we set onClick to onClear. We have a compilation error because I forgot to include it right here. Okay, we're done with this step. Next, we go to the app component, and here we set onClear to a function. In this arrow function, we simply call set cart items and pass an empty array. So because this is where we maintain the state, all the updates should be done in this component. Now, by the same token, if we wanted to allow the user to remove a particular item from the shopping cart, we would have to pass a new prop here, like onRemove, which would be a function that would take a product, and then we would have to Remove that product from the shopping cart items array. Okay, so let's not worry about it now. Now, that would take a product, and then we'll have to remove that product from the shopping cart items array. Okay, so let's not worry about it now. Now back to the browser. Look what happens when I click the clear button. So on the navbar we have 0 and our shopping cart is empty. So these two components are in sync. Alright, we're done with all the materials in this section. Now it's your turn to put what you learned in practice. So for your exercise, here we have a game object with a couple of properties, ID, which is a number, and player, which is an object with a name property. Now let's imagine that when the user clicks a button, we're going to set the name of the player to something else. Now typically outside the React world, we would write code like this. We would set game.player.name to, let's say, Bob. But you know that this is not the right way to go about this in React applications. So pause the video and spend a couple minutes on this, then come back see my solution. Bug. And now for this example, let me comment out this line. Now to use immer, we call, now by convention, we call the parameter of that proxy object that records the changes we're going to object. A cop draft. Now, if we find of updating object above the button, we're going to map the area. For the text, we're going and spend a couple minutes. On this, then come back see my solution. We set the key map, of course, the JavaScript we're going to apply to the bugs array. So imagine draft is a copy of the bugs. Any changes. Imagine a bug with the ID hitting this object just like a. Now to verify that this is working, let's render a bit. this style of updating objects in an immutable way, you can use immer to simplify your update logic. Now, to verify that this is working, let's render my solution. All right, here we call set game. It's not here, the player object there, to copy all the properties of game.player, and then we overwrite the name property. All right, here's your second exercise. For this exercise, we have a pizza object with two properties, name which is a string, and toppings, which is an array of strings. Now, let's say when the user clicks this button, we want to add a new topping to this array. to pass. Now, shopping cart, and here are pretty simple so far, nothing new. Now, back to the browser, be in sync. How can So here in the app component, a list of shopping an array. The other option is to pass only their count. What is the difference? Well, we name this property to cart component. So we add a new component, X, let's add that here, because we are returning, and we're going to use the item as the table as well. We're almost there. Now, let's go to the app component, array of strings. Now let's come back see my solution. The spread operator, use the operator to copy all the existing toppings in the pizza, and then we add our new topping. As simple as that. All right, here's your next exercise. For this exercise, we have a shopping cart object with a couple of properties. Discount, which is a number, and items, which is an array of objects. In each object, we have three properties: ID, title, and quantity. Now let's say when the user clicks on a button, we want to change the quantity of this product to 2. So spend a minute or two on this, then come back see my solution. All right, here we call setCart and pass a new object. First, we spread the existing cart object. Then we set the items property to. Now here we need to go in the items array and update only one of these objects, the object with the ID of 1. To do that, we use the map method. So here we call cart.items.map. Now here we pass an arrow function. Item goes to. Now we need to check the ID of the item. If the ID equals 1, we're going to create a new object with the updated quantity. Otherwise, we're going to return the same item. So here we use the ternary operator. We say if item.id equals 1, we return a new object. Now, in this object, first, we need to copy all the properties of this item. So we spread it, and then we add the updated quantity. We could also set this to item.quantity plus 1. So if item.id equals 1, we return this new object. Otherwise, we return the same item object. Now, I know this syntax is a bit ugly. All these braces and stuff just makes it hard to understand what's going on. This is why you should prefer to use Immer. But I wanted you to do these exercises without Immer because a lot of React projects are built this way, so you should be comfortable writing update logic in this way. All right, as your next exercise, I want you to build a component called expandable text. So we can pass a long text here and this component will summarize the text for us. Now, by default, we only see. I want you to build a component called expandable text. So we can pass a long text here, and this component will summarize the text for us. Now, by default, we only see the first 100 characters, but this can be configured using a prop. So here we can set max chars to, let's say, 10, and now we only see the first 10 characters. Now, if the text is summarized, we see a more button to see the entire text. We can also click on less to summarize the text again. This is a very useful component. So spend 15 to 20 minutes on this exercise and then come back see my solution. And by the way, if you get stuck, don't worry. This is part of your learning journey, so don't be hard on yourself. You're still learning. So do your best to finish this exercise on your own and then come back see my solution for additional tips and tricks. and this component will summarize the text for us. Now, by default, we only see the first 100 characters, but this can be configured using a prop. So here we can set max chars to, let's say, 10, and now we only see the first 10 characters. Now, if the text is summarized, we can pass a long text here that Mac also click on, let's say, 10, and now we only see the